I'm Bryan DeLuca, and I am here at APEC with Jason Lemke at the Teledyne LeCroy booth, and he's going to show us what's new.
Yeah, there's something really exciting that we're announcing at the show, which is our new CP1000 current probe. This is 1,000 amps, and it is rated to 1.5 megahertz, which is an industry-leading specification. Why are people interested in doing 1,000 amps? Because we've got companies in EV space, in the data center space, that are pushing more and more power. And so they're looking for ways to measure that more and more power. And as we know, power is voltage and current. So that's one of the pieces of the equation, is how do I measure more current? So this will give you very high currents and at a bandwidth that nobody else can approach. And the bandwidth is going to be important because we're hitting higher and higher switching frequencies, higher and higher rise times, which means you're going to want a probe that does 1,000 amps at high bandwidth. But that's not the only thing that we need to do, right? So we've got this probe, there's a signal coming out, we got to take it to an oscilloscope.
So before we move on, this pretty much will go with most of your scopes?
This will go with, I think, all of our scopes. It's just been released right now, so I'm still learning about it myself. But as long as it's a LeCroy scope that has our Pro Bus connector, you should be able to plug it in. The scope will automatically detect that it's a probe from us, and will give you a couple of extra buttons to press to be able to degauss it and auto zero it, etc. So yeah, it's automated with the scope. Yeah, let's go.
Let's go look at the scope.
Let's go check out the scope. So obviously, then you got
a scope.
Yeah, you got current, and you got voltage, and you now want to go ahead and put that on a screen that you can see.
This is the probe. This is the piece you're talking about.
That is, yeah. That is the integration of the probe to the scope on the front end. And so you're going to pull in, this is an 8-channel oscilloscope. So if we're doing like 3-phase power measurements, we might have 3 voltage probes and 3 current probes for each of the phases. And so that's what you're looking at here, is we're driving a motor. We're looking at the pulse width modulated waveform coming out of the voltage. We're pulling current. And what we're actually doing here is we're watching that voltage and current as the motor starts to ramp up. So it gives you a very dynamic picture of what's happening as this motor is starting to drive. And so that's kind of cool, because then once we have the waveforms, we can start moving into, okay, what are the things that are of interest in the waveforms? Maybe we're looking at our volts RMS, maybe we're looking at our currents RMS, maybe we're looking at power, we're doing all these types of measurements inside of the scope. We're automating it, we're simply putting it in a table so that you can quickly and easily see what's going on in your system. Then if you want to get into some more detailed measurements, like what's happening in this current waveform at the start, we can really drill down to that specific portion of the waveform, and we can start making really detailed measurements about that.
Very cool.
Yeah, so these are things that we do at LeCroy. We try to make everything available to you. Once we acquire the data, we give you all the different ways to go ahead and present that data. And if you've got really specific measurements that nobody else is doing, we can find a way to do it in these scopes.
Well, Jason, thank you for your time. It was a pleasure.
Nice to meet you.
You too.